Hi everyone, and welcome back to the Coding Classroom. Today, we're diving into one of the most important topics in programming, methods. Whether you're just starting out or looking to sharpen your skills, understanding methods is key to writing efficient and reusable code. In this video, we'll break down everything you need to know about methods, what they are, how they work, and why they're so essential. Let's get started. Let's start by answering the question, what are methods? Methods are a collection of statements grouped together to perform a specific task. Think of them as mini-programs within a larger program. They help make your code more organized, modular, and easier to manage. Methods are primarily used for reusability. Instead of rewriting the same code repeatedly, you can define the code once inside a method and use it multiple times. This not only saves time, but also reduces redundancy and potential errors in your code. Here's an example of how methods work in Java. Public class main, public static void main string args, system.out.println finding person, int person if find person Sam 26, system.out.println person, public static int find person string name int age, system.out.println found name, return 3. When the method find person is called, the program jumps to the method's definition, executes its code, and then jumps back to where it was called. Let's take a closer look at the key components that make up a method. Understanding these components will help you write methods effectively and make your code easier to maintain. Access modifier. This determines where the method can be accessed from. For example, public makes it accessible anywhere, while private restricts access to within the same class. Static or non-static. This defines whether the method belongs to the class itself. Static, or to objects created from the class, non-static. Static methods are great for utility functions, while non-static methods are used for object-specific behavior. Return type. This specifies the type of value the method will return, such as int, string, or void if it doesn't return anything. The return type ensures the method produces a consistent and expected output. Method name. This is the name you'll use to call the method. It should be descriptive and follow naming conventions like camel case, making it clear what the method does. Parameter list. Parameters are the inputs the method needs to perform its task. They're written inside parentheses as data type variable name. For example, int a, int b in a method for adding two numbers. Method body. This is where the action happens. The body contains the logic that defines what the method does. It's enclosed in curly braces and can include anything from calculations to printing text. Return statement. If the method has a return type other than void, it must include a return statement to send the result back to the caller. For example, return a plus b. Each of these components plays a specific role in how the method works and interacts with the rest of your code. By mastering these, you'll be able to write methods that are both functional and easy to understand. The method name is how you reference the method in your program. It should follow camel case convention, e.g. find person. Avoid starting with digits or using special characters other than or dollars. Be descriptive and concise to clearly indicate what the method does. The body of a method contains the logic that performs the method's task. For clarity, a method should focus on one specific task. For example, public static int add int a, int b, return a plus b. This method adds two numbers. Parameters are the inputs you pass to a method to customize its behavior. For example, Arduino copy code public static int multiply int a, int b, return a, b. Here, a and b are parameters, and the method uses them to perform its calculation. Parameters are enclosed in parentheses and written as data type variable name. A return statement allows a method to pass back a result to where it was called. For instance, public static int square int x, return x to x. When you call square 5, it returns 25. If a method doesn't return anything, it is declared as void. Access modifiers control where and how a method can be accessed in your program. There are four main types. Public, accessible from any class, typically used for methods that need to be universally available. Example, public void greet, system.out.println, hello world. Private, accessible only within the same class, often used for internal logic or helper methods. Example, private void calculate, system.out.println, performing calculations. Protected, accessible within the same package or by subclasses, useful for inheritance. Example, Protected void display info, system.out print displaying information. Default, no modifier. Accessible only within the same package, used for package-specific functionality. By choosing the right access modifier, you can ensure your methods are appropriately secure and only accessible where needed, following best practices in encapsulation and object-oriented design. Static methods belong to the class, while non-static methods belong to objects. For now, we'll focus on static methods. They are simpler and can be called without creating an object, like this, math16. This is an example of a static method provided by Java. The main method is the starting point of any Java program. It looks like this. Public static void main string args / program execution starts here. Without this method, your Java program cannot run. An object is a complex variable that represents an entity in your program. It's a collection of methods and variables that together define its behavior and properties. For example, person me equals new person. Here, me is an object of the person class. Mutator methods, or setters, change an object's state, while accessor methods, or getters, retrieve data without altering it. For example, public void set height int height. This.height equals height. Public int get height, return height. These methods are crucial for encapsulation and data protection. Method overloading allows multiple methods to have the same name but different parameter lists. For example, public int find person string name, public int find person string name, int age. This makes your code more versatile and easier to read. Here's a practice example. Private static void summon bees into mount string species. For in I equals 0, I to mount I++, system out print buzz. Questions. How would you call this method? Where can it be accessed given it's private? What does the method do? Let's answer the questions from the practice slide. To call the method, you would use summon bees 5 honey. Since it's private, it can only be called within its own class. The method prints the word honeybuzz 5 times, but doesn't return anything since it's void.
Thank you for watching this video. Make sure you like it and subscribe.